Okay, so the fundamental theorem of calculus, and really what this does is it ties together differential calculus, right, finding the derivative, with integral calculus, the problem of area. And when calculus was being developed, and actually I have some videos, I might play a video on the development of calculus. When we're done this, just sort of in the background, and you can either sort of watch it. It's sort of like who was first, Newton or Leibniz, and that. And really the idea was to take those two different concepts, one being the slope of a curve and the other one being the area under a curve, and to say, hey, they're actually related. So by definition, the integral from a to b of f of x dx is the limit as n approaches infinity of the sum of I equals 1 to n of f of x sub I delta x, where delta x is the height, right, the infinitesimal height of infinitely many rectangles, right, which is what we're doing here, or the Riemann sum. And we also know that for cases where f of x is positive function, right, where it's above the x-axis, that this integral is the area under f of x from a to b, which is equal to f of b minus f of a, where f is any antiderivative of f, right? And it's any because we're subtracting, so if you're adding on a constant, you're subtracting it off, right? So generally we don't bother. It's like, okay, we're not going to do the constant because we know we're going to be subtracting it off. The statement integral from a to b of f of x dx is equal to f of b minus f of a, where f is any antiderivative of f, is true for any continuous function f, whether the function is positive or not. So as long as we have a continuous function, what this really says is that there is an antiderivative for any continuous function. Yep. Yep. Need help on it too, or timeline?
No, I can.
And so here, and sometimes it's split up into two parts. So in future studies, you might see the fundamental theorem of calculus part 1 and the fundamental theorem of calculus part 2. But if f is a continuous function on a closed interval a, b, then the integral from a to b of f of x dx is equal to f of b minus f of a, where f is any antiderivative of f. Another notation for this, really the difference here is this thing here, right? So we just say f of x, again, where f is any antiderivative, and this really simply translates to that.
Calibrate it.
Hang on, I've got to pause.
Calibrate it.
Okay, so evaluate. So this is called the definite integral, right? Because it has numbers on it, right? So we can actually evaluate it. So the definite integral is a number. And it would be the number, which is the area under the curve, if this were all positive, which this one isn't, right? Because it goes negative 2 to 4, so there's part under and part above, so it's not that. And so this is equal to, so we just write equals. We take an antiderivative, right, which is x to the 4th over 4, which we are going to evaluate in the interval negative 2 to 4, which is equal to, so we start with the upper, so it's 4 to the 4th over 4 minus negative 2 quantity to the 4th over 4. Okay, so watch your negative signs, parentheses, blah, blah. Check that this really is, right? I mean, it's like factoring, right? When you factor, FOIL it out. Somebody factored incorrectly, got the wrong sign. Actually, they factored correctly. They factored out a negative incorrectly, which then caused the answer to be thrown off. And that's like a half mark kind of mistake, right? But anytime you factor, multiply it out, just make sure, especially when you're factoring on a negative sign, just make sure that the signs are correct. Anytime you take an antiderivative, take the derivative. Make sure, okay, so that's 4x cubed over 4, which is x cubed. All right, so that's just going to be 4 cubed, which is 64. And this is going to be 16 over 4, which is 4. And that's 60.
The one that I got right now.
Okay, so 4 to the 4th over 4 is 4 cubed. 4 cubed is 64. And negative 2 quantity to the 4th is a positive, which is 16 divided by 4, which is 4. And interpret what this means. So if we think about, well, what does x cubed look like? And it's from negative 2 to 4. So it's the sum of two areas, right? So we have this area here. So let's call that A1. We have this area here, and let's call that A2. And so what this says is that A1 minus A2 is equal to 60, right? Because this is a negative area. Okay, because it's below the axis. So that's what's going on here. If we wanted the total area, then we could take the absolute value of this one and this one. We can't take the absolute value of this. Right? We take separately compute the two areas, take their absolute values, add them together. All right, example 2, evaluate. It's nice because I got some space here. So that equals, now what do we want to do to this first? Like, what would be the smart thing to do?
Expand it.
Expand it, right? Multiply, because we need to do an antiderivative. You don't want to sort of treat this as a product and, like 20 minutes later, this test is too long, right? Why? Because you chose the wrong strategy to do a problem. So, and it's a thing, right? Any test-taking strategy at this point, and you should by now, last class in grade 12, have sort of figured this out, right? Is if a question's taking too long, leave it, go on and do something else, and then come back to it later. Maybe take a fresh approach at it. So let's just rewrite this as the definite integral from 2 to negative 1 of 3x squared plus 6 minus 1, so plus 5x, minus 2 dx, which is equal to, and so now we're going to take the antiderivative, right? So the antiderivative of 3x squared is x cubed plus 5x squared over 2, or 5 halves x squared, minus 2x in the interval negative 1 to 2. Okay, so first step, simplify the thing of which we have to take the antiderivative. Okay, into, oh, well, that's very nice and easy to do the antiderivative. Take the antiderivative and then evaluate it. So starting at the upper limit, we've got 2 cubed plus 5 halves times 2 squared minus 2 times 2. I can enclose that in brackets. I certainly don't need to, right? But the reason I do that is because now I'm subtracting another expression, right? And so this one has to be enclosed in brackets because we have to change the sign. So I put in more brackets than are required. Okay, and we've got a couple of choices. Of course, we can just evaluate the first bracket and evaluate the second bracket totally, and then subtract one from the other. We can just rewrite this without brackets. So I don't know what you prefer, but I'm just going to rewrite it without brackets. So we're just going to go through and evaluate each term and write that down here, changing the sign of each of these guys, right? As we evaluate this and get negative 1, we'll change its sign. And we evaluate this, get a positive, we'll change its sign, and so on. Okay, so that's equal to 8. What's the next one? Plus 10, right? You can either 2, take away the 2, right? Or not take away, but, cancel. Plus 10. Minus 4. Okay, minus negative 1. So we're going to write that as plus 1. Negative 1 squared is 1. This is plus 5 halves, so we're going to write minus 5 halves. And this is minus negative 2, which is plus 2, which becomes minus 2. And so, what do we get? 18, 14, 15, 13, minus 2.5, like 11.5, or 21 over 2. I mean, 10.5. Always check your test when you get back, so make sure that I did my arithmetic correctly and added up the numbers at the bottom of the pages correctly. Yeah. You accidentally misadded 3 plus 3. Sometimes you miss things, I don't know. Okay, so what do we want to do with this one? divide everything by t, right? If we divide everything by t, this will be a lot easier to do, right? Because again, otherwise, how do you treat this, okay? And so, yeah, we say, hey, you know what? Let's do the integral from 1 to 4 of t plus, so what's this? What's my second term? So we got t to the half divided by t, which is half minus 1, which is? Okay, because the other thing is, I don't want to write that necessarily as 1 over root t, right? And I don't want to write root sign in there either, because I need to do the antiderivative, so I need a power on there. Okay, and then what do we get? Minus 2t to the negative 1, right? And what else? dt. Okay, so now we can do the antiderivative. So let's go over here. So that equals, okay, so t squared over 2. And now what? So t to the what? T to the half. So we've got to add 1, right? Okay, and then I've got to divide by a half or multiply by 2. So let's multiply by the reciprocal. Okay, so minus 2, that's kind of written a little awkwardly. Okay, so check that out, right? A half times 2 is 1. It'll be minus 1 t to the negative 1 half. Wait a second.
No, it's not negative.
So it's positive. Okay, that's why we check that out. Okay, now what do we got? 1 and then t to the negative half. Okay, good. Right, that's what we got to watch, especially with signs. And then what's the last one? We can't add 1 to t to the negative, so it's ln, right? Yeah. Ln of what? Absolute value of t. Absolutely. Right? That's worth a half a mark. Or a half a mark off. But only once, right? So we didn't, it's like if you forgot the plus c multiple times, we only took a half mark off. If you forgot the plus c once, we still took off the half mark. So not every time. Yeah, that would have cost somebody like 5 marks on that 10-mark question. I never wrote plus c.
I just started by writing plus c for all.
Yeah, that's right. Just end with plus c. If you want to mark higher than a c plus, then don't forget the plus c.
What's a c plus? I thought about doing that for one.
I have no idea. There's letter grades and there's like, so, I mean, most of you are going off to university and most of them use GPAs, which are a 4-point, right? So 4.0 is the highest mark you can get. It really translates to about a 95 to 100 or 90 to 100, depending on the course and the university or whatever. And then that would be like an A or sometimes an A plus. Like, so that's an A, but they could give you an A plus if they thought like you're really good. They could put a letter grade of A plus. But then about every 0.3. So like 4.0 is an A, 3.7 is a B plus, 3.4 is a B, 3.1 is a B minus.
That's pretty
A minus 2.
Oh, I don't know. A minus 2, A minus 3.
A minus 2.
It is minus 2.
Yeah, it's like 3%.
Yeah, that's true. There is a.
GPA based on your whole classes.
Okay, and then again, I'm going to throw brackets around that. Just I don't need to, but I just like to separate it off, you know, because that way I won't forget to throw brackets around this. Okay. And now your choice, right? I mean, you can evaluate each bracket, or now I'm just going to go through and write everything, simplify it and removing brackets. So we got 16 over 2, which is 8. We got 2 times the square root of 2, which is 4. Minus 2 ln 4. And the absolute value of 4 is 4, right? So that's that. Minus, now I got to remember, as I'm evaluating these, I'm changing their sign. So it's minus a half. Minus 2. And what's the natural log of 1? 0. So then, well, let's go plus 0. It's minus negative 0. Not true. So, and the only reason I'm writing this is because you can do a one-to-one correspondence with what's above, right? So if you're looking at this, you're sort of not going, what happened to this term? That's plus 0. At which point you go, why is that 0? And then you go, the ln of 1 is 0, and then, oh, okay, right? So that you at least know you didn't just leave it off, right? It's not a mystery. You just left that last term off. Why did you do that? Okay, so what do we got? We got 12. Minus 2 is 10. Minus a half is 9.5, right? Or 19 over 2. Minus 2 ln 4. Do we want to say it as 2 ln 4? Sure. Minus 2 ln 4. But then what can we do with that?
Bring the 4.
Oh, no, sorry, the 4 is there. What do we do with the 2? Yeah.
Bring it up.
So it's 19 over 2 minus the ln of 16. Okay. And that's where the 16 came from, right? Again, if I had just gone and written the 16, you'd be going, where did 16 come from? And you can see how it changed from this to this to this. Sort of reminding you that, hey, if there's a number in front of a ln, then we should bring that number up as an exponent, right? Okay. Questions? Comments? Yeah.
Would you expect it like that on a test, or
I would expect that.
would you accept that on
Are you?
Lower your
how-
expectations.
Yeah. I'm always more forgiving of the mistake that I made when I marked yours. Well, I made that mistake, therefore I can see that any reasonable person might make that mistake. Sec squared 2x dx. So we're not really going to simplify that any, right? So who's the derivative of what is sec squared? Tan. Okay, so we write tan 2x. Okay, what's the derivative? And you divide by 2, right? Because the derivative of tan 2x, the chain rule says you're going to get a 2, so we need to put in 1/2, right? All right, so it's 1/2 tan 2x, and then we're evaluating that from negative pi by 8 to pi by 8. I was saying like pi by 6. I was asking my 20-1, so what's the cosine of pi by 6? Of course, they haven't got a clue, but so one guy was doing cos 6 pi, right? Pi times 6. That's, oh, pi by 6 is. So it's interesting what we pick up. So this line is just the direct substitution, right? I haven't done anything special here yet. And I didn't simplify that in. Oh, sorry, pi by 8 first. This line is almost a direct substitution. Okay, this line is the direct substitution. And so now we go 1/2. 10, well, 2 pi by 8 is pi by 4. Minus 1/2, 10, and this will be negative pi by 4. What's the tan of pi by 4? 1. Nice number, right? So 1/2 times 1 minus 1/2. What's the tan of negative pi by 4? Yeah, see, think, I just sort of imagine tan and say, well, there's 1, there's negative 1. So what's 1/2 of 1 minus 1/2 of negative 1? 1. Right? Or 1/2 plus 1/2, or 1. Ooh, 1 page down, 1 to go. 6x over x squared plus 9. Good. So, what are we going to do with this? So let's split this up and treat it as 1 over x squared plus 9 times 6x. So, what are we going to do? How do we get a 1 over x squared plus 9? Okay, so we could do the ln of the absolute value of, even though x squared plus 9 has to be positive, right? But still, let's, you should always be in the habit of writing the absolute value of. Okay, and then chain rule says when I do the derivative of ln x squared plus 9, I get 1 over x squared plus 9 times 2x, and I need a 6x, so then we're going to throw a 3 in here as well, right? And where's the best place? Well, let's throw the 3 up front. So it's 3 times ln of x squared plus 9, evaluated from 1 to 4. Okay. No, let's just plug in and then worry about what we have. Right, because it's 3 times. Yeah, eventually we will. So it's 3 ln, okay, so that's equal to, so it's 3 ln of 4 squared plus 9 minus 3 ln of 1 squared plus 9. So at this point, 4 squared plus 9 is 25. The absolute value of 25 is, and 1 squared plus 9 is 10, the absolute value of which is 10. So we got 3 ln 25 minus 3 ln 10. So here, let's play some simplification games. So let's factor out the 3. We've got ln minus ln, which is simplifies 2. The ln of it, the difference of lns is the ln of the quotient. Okay, so that gives us 3 ln 5 halves. Or ultimately, ln of 5 halves cubed. Or the ln of 125 over 8. Okay? So why do we do all these different forms? Well, if it's multiple choice, you may see anything along the line, right? Maybe you see ln of 125 over 8. And you're going, darn, I've got 3 ln 25 minus 3 ln 10. And you have to realize that, oh wait, they're the same, right? Which might not be an instant realization, but just take a little bit of working through to say, right, okay, yeah. So in other words, if you see answers that aren't in the form you have, then you want to keep working with what you've got. All right, what could I do with this to get it into so it looks like one of these guys? 2 sine theta cos theta. Okay, so what do you want to do with that? Use the identity and change it to? So what is it? Sine 2 theta? Okay, so we can do that. And what do we get for an integral then? Or an antiderivative? Okay, so cos 2 theta. What's the derivative of cosine? Negative sine. So we're going to need a negative 1/2, right? So this will be negative 1/2 cos 2 theta. Right? So again, just a little check here, right? I mean, what's the derivative of cos? If you just write the cos 2 theta, because you sort of know it's related, you'll get negative sine 2 theta, and then you say, oh wait, and then 2. So I need negative 1/2, right? To counteract that negative 2. Okay, and now we go negative 1/2 cos of 2 times pi over 2 minus negative 1/2 cos of 2 times negative pi by 3. So what do we got? negative 1/2 cos pi minus negative 1/2 cos negative 2 pi over 3. Okay, what's cosine of pi? Negative 1. Right. So I don't know how you guys do it. I just imagine, like I don't do the unit circle for sine and cos of pi's or pi over 2's. I just sort of imagine, hey, what's the curve look like, right? Oh, okay, so negative 1. Now, for this, I do have to do unit circle and reference angles and all of that good stuff. So what's the cos of negative 2 pi over 3? Which quadrant is it in? In quadrant 3, that makes it negative. Okay. And it's got a reference angle of? The reference angle pi by 3. And the cos of pi by 3 is? A half? Yeah, so then it's negative a half. Okay, so what do we got? What do we have? That's a half. No, that's a quarter. Half minus a quarter, which is 1/4. Can we do this another way? So is there another antiderivative? What's the other antiderivative for this? For this, sorry, for this really. Okay, so if we do sine squared theta, what's the derivative of sine squared theta? No. Yeah, it's 2 sine theta cos theta, right? So we've got sine theta all squared, right? So change, so that's 2 times sine theta times the derivative of sine theta, which is cos theta. So we could just do sine squared theta from negative pi by 3 to pi by 2. So sine squared pi over 2 minus sine squared pi over 3. So what's the sine of pi over 2? One. And what's the sine of pi over 3? Root 3 over 2, right? So that's 1 minus 3/4, or 1. I mean, they can't come out different, right? But just shows you there's a couple of different ways to do it, right? The second of which is a little bit easier, I think. But, okay, or way easier. But, it doesn't matter, right? It's going to work out. Either way you do it, just, they can work out very simply, or it can work out a little more difficultly. Yeah, well, yeah. A lot of places to mess up. I got to do cosines of negative 2 pi over 3. Here I'm just sitting in the first quadrant pretty much, and those are pretty easy numbers to work with, right? But that's the difference between the test is too long and whatever. But if you start getting into this, maybe you get to this point here and you just sort of say, I'm just going to put this aside for a while and I'll come back to it. Like I can work this out. It's just going to take me a little while, right? And it's worth, at this point, it's worth what? Maybe 1 mark or something to get that. So let me go get some other marks and then come back to it later. So you have to sort of gauge your time. Indefinite integrals. So a definite integral is a number. An indefinite integral is a function of x. So we use the symbol capital F of x to denote the antiderivative of f of x. By the way, a lot of places don't use this little dash here, right? So, and I haven't been when I've been writing. And your book doesn't either. It just does antiderivative as one word. We will now use the indefinite integral symbol to denote the antiderivative. So when we talk about the antiderivative, we're talking about capital F of x or the indefinite integral, right? Indefinite. And the indefinite integral is a function. And remember, there's some arbitrary constant that you can add on. So we need that there. And the definite integral is a value. Okay, it's a number. And so we got a few to do, and then, so the indefinite integral of x to the n dx using the anti-power rule. What's this? Plus c. Also called the general, right? We on the test it was the general antiderivative. That's why you had to add c to all of those guys. The integral of 1 over x dx is ln of the absolute value. Why do we have to do absolute value? Well, because x could be negative here, but if you do it without, x could only be positive. You're doing the natural log, so we need to take that. So, hey, we just did this one. So this is we done? Or some. Oops. Plus c. How about the cosine of kx? So sine kx, so this is where I would start, right? Sine kx, that gives me cos kx, times k, so I got to undo that, so 1 over k, plus c. E to the kx dx. E to the kx. Derivative of kx is e to the kx times k, so we got a 1 over k to take out the times k. So let's go 1 over k plus c. B to the kx. Oh, not so easy. So we have to do a little something here, right? B to the kx. Like, if it were e to the kx, that would be easy, right? So here's the thing. What can I do with b? So I think we got some room on the page. So let's skip up to here and say b is equal to e to the power of what?
Natural log
Actually, natural log b. So we're saying, what do we raise e to get b? Well, the inverse of e, so the natural log of b, right? So b is equal to e to the ln b. So what's b to the kx equal to? It's e to the ln b to the kx, which we can simplify by doing what with the powers? Multiply. So let's call this kx ln b. Right. So this and this are the same, which means that the integral of this, well, the integral of this is the integral of this, right? So let's do the integral of e to the kx ln b. Okay, so what is that? What's k ln b? It's a constant, right? It's a number. It's got nothing to do with x. So k ln b is a constant. So the antiderivative is e to the kx ln b. So you take the derivative of this, you're going to get e to the kx ln b times the constant, which is k ln b. So we got to multiply by 1 over k ln b. Plus c. But what's this? Right? So what do we get? 1 over k ln b times b to the kx. And that's that. It's on your formula sheet, so don't panic. But that's where it comes from. Okay, so if you're doing the integral of b to the kx, although I think on your formula sheet it's got an a instead of a b. But, okay, so 1 over k ln b, b to the kx plus c. This is kind of good introduction for tomorrow. I think we do integration by substitution. In a sense, we're sort of substituting something here, right? To make it easier. So derivatives, finding derivatives is a mechanical process, right? I mean, when you follow the rules, where you get the power rule, you get the quotient rule, you get the product rule, you get the chain rule, and it's just a mechanic, you just keep doing it, right? When do I stop doing it? When there's nothing left to do, right? Especially chain rule, when you're into your 5th thing, it's like eventually at some point it stops, right? Doing integrals is more of an art. Okay, so it's a little bit, but we don't do too much of it, right? What do we got? A few more days. You look at your outline, there's not that much left. Okay, so